So certain right triangles follow certain special rules, and we're expected to know them for the GMAT. Now, there are two rules that are related to the actual angles of the triangles, and those are triangles that have angles of 30, 60, 90 and 45, 45, 90. These are two types of special right triangles. Now, the other sorts of right triangles that we're supposed to know about are triangles that follow a particular ratio of the length of their sides. So these are triangles where the sides bring about the special or important unique property of the triangle. So looking at the angles first, the thing we're supposed to know about a 30, 60, 90 triangle, if I draw out a version of that here, is a 30, 60, 90 triangle has a particular ratio of its sides. The shortest side, which is across from the 30, will have a length of 1x. And the side across from the 60 will have a length of x root 3. And the side across from the 90-degree angle will have a length of 2x. And if you plug this into Pythagorean theorem, you will get x squared plus x root 3 squared equals 2x squared. And what you find is you'd get x squared plus 3x squared, because you square both the 3 and the x separately, but keep them multiplied. And then doing the same idea on the right-hand side, you'd get 4x squared. And 1x squared plus 3x squared equals 4x squared. So that shows that this does follow Pythagorean theorem, and this ratio will always hold when you have a 30, 60, 90 triangle. And if you see sides that look like this in a ratio of x to x root 3 to 2x, and they don't tell you about the angles, you still know that you have a 30, 60, 90 right triangle, because only 30, 60, 90 right triangles have sides that follow this ratio. Now, 45, 45, 90 triangle is what's known as an equilateral right triangle. It's a right triangle that has two equal sides because they have two equal angles. So the sides across from the 45 degrees are going to be of the same length. And again, we'll call those x for this triangle. Now, in that situation, if we have x squared plus x squared as our Pythagorean theorem, we'll get 2x squared out on the right. Now, if we square root everything, we will find out that c squared, which is the right-hand side of Pythagorean theorem, so this would be a squared plus b squared equals c squared. C squared is 2x squared. That would mean c is actually x root 2, because when we square it, we'd square the root 2 and that would become a 2, and we'd square the x and that would become an x squared. So we know this side is x root 2, and this will always hold for 45, 45, 90 triangles. Now, these three that relate to sides, these are only special because you can see very quickly that they are a right triangle by recognizing the ratio of their sides following a ratio of 3 to 4 to 5. So we discussed in another video that 3, 4, 5 is a common right triangle because a squared plus b squared equals c squared, and that only happens in right triangles. And the same will happen in a 5, 12, 13. A squared plus b squared equals 13 squared. And so that means that it has to be a right triangle. Now, we know nothing about the angles of these triangles, or we're not expected to, but these three will always guarantee that we have a right triangle. And in fact, even if they're in a ratio that follows this ratio, so 6 to 8 to 10 is a 3 to 4 to 5 ratio, this will also have to be a right triangle because 36 plus 64 equals 100. And it will always work out that if you follow these ratios, you are guaranteed to have a right triangle.